Welcome again to Atomic Friday, and it's great to be back. It's been a bit, been a little while, I think. November, maybe July or something, I don't know. But thank you for joining, and going to quick reminders. If you have any questions, drop them in chat. I think there's a Q&A box. You can throw it in there. You can also drop it into the general channel on our Atomic Red Team Slack group. And from there, yeah, this is also being recorded. So we will ship that out after. I believe we do that via email, and it will be on the atomicredteam.com webpage. So with me today, going to be me, Michael Haig. Good to be back, and I would let Matt and Carrie introduce themselves.
Yeah, hey, I'm Matt Graber. I'm the Director of Threat Research at Red Canary. I've been here just over 3 months now. As for Atomic Red Team, I'm relatively new to it, but fortunately, we're here to talk about PowerShell, which is very near and dear to me. So there being, by the nature of there being a dedicated PowerShell runner for Atomic Red Team tests, it was only natural that this be like the perfect opportunity for me to really dive into the Atomic Red Team framework. And so I'm pretty excited to show some of the new functionality that I've helped incorporate into the PowerShell runner. Carrie?
Yeah, Carrie Roberts here. I'm a dynamic defense engineer at Walmart, and I've got involved with Atomic Red Team back in about July. And at the time, I had heard some things about it, heard some excitement about Atomic Red Team, didn't really know what it was, and then got started with, got excited about it, and been contributing since. And also excited to have Matt joining and contributing here. That's been exciting and helpful to have another interested individual contributing to the project.
Yeah, if anyone's been following along, there's been quite a lot of contributions over, gosh, the span, Carrie, since you started on working on it all is really when it really started to kick up. Between just the Atomic Red Team additions, just as far as the atomics go, and then with the Invoke-Atomic repo, which we'll mostly be talking about today and highlighting live, all of the live actions from that. So I'm just going to switch gears here and flip over to my VM, and we'll get started. We have a lot of live content today, so I hope that you are ready. Again, this is recorded. All of this will be available after, and hopefully everything you see on my screen here, you'll be able to follow the recording and then also see my notes on the right-hand side of my VM here. And we'll just get going. And if anybody wants to drop any notes or questions or comments, we will do as best as we can to answer them live and go from there. All right, so to get started, I'm going to be working with Invoke-Atomic Red Team. And this is the execution framework, the PowerShell execution framework that we had in the original Atomic Red Team repo. We've separated it. And this now allows for us to be able to kind of have more control over where your atomics folder is. The atomics folder being all the T numbers, all the T items and everything like that from the Atomic Red Team project. And so this is the Atomic Red Team project with all the T numbers from the atomics folder. And so each one of these you can pull out and use individually, and that's where the Invoke-Atomic project comes in. And Carrie has been contributing the most to this, and a lot of this is amazing. There's so much fun stuff in here, and I'm pretty sure I find something new every time I run a command. But that's the cool part about it. There's super dynamic, and Carrie and Co is really producing a lot on here. With that, if you haven't played with it, this is where you'll most likely want to begin if you're just starting with Windows framework or Windows execution. And so what I did, if you probably saw me on the screen here, I went right to the wiki. And so we have all of this documented in the wiki. And I'm going to showcase a little bit right down here, and then I will do most of it live from my PowerShell terminal. So to start, if you want to just download the execution framework itself, it's as simple as copying these 2 lines. There's not much more beyond that. And this will download it, put it into your C Atomic Red Team folder, and you'll have a new Invoke-Atomic directory here, and that has the whole execution framework. It will also import the module, so you're ready to go on your terminal pretty quickly. The one that I'm using, or I had used, and to save time, I went ahead and already ran it, because when you download the Atomics folder, there's like this long span of time where it has to download everything. So this will download the execution framework and the Atomics folder. So what you see in my C Atomics is both of them are already there. So we're already like 1 step ahead. And then from there, you already have, if you open up you'll already be in a PowerShell terminal. So really, you already have the module loaded, you're ready to go. So you can run Invoke-Atomic Test. So I'm gonna flip to my notes over here, highlight a little bit about what I'm working in and a little bit more details right before that installation had happened. So in this particular case, I'm using Detection Lab. This provides like a lab environment with all of, with a Windows 10 VM, Windows Event Forwarder, and there's Splunk in there, there's a domain controller. So this is a domain joined system. So we'll be able to showcase a remote execution, or remote execution just because there's another Windows box involved. So a little bit on that. And then what I'm using, again, this is Windows 10, 18.362, PowerShell version 5.1, so just everything on my box. And we talked about that installation. So you copy those 2. This will install Invoke-Atomic. It'll also grab that Atomics folder from Atomic Red Team. Couple notes for your execution policy. If you're doing this, either you're doing it in Detection Lab or your own machine, you'll need to either set it to unrestricted on your user or just in general on your session. And you will most likely need to disable antivirus. If you're doing it in a lab, you may already have it disabled. If not, you'll want to disable it and maybe not run it on a corporate owned machine. There's so many things it'll flag. All right, cool. Yes, I will ship these notes out as well because they are nice and clean for sure. And it's just Markdown, so it's easy. And then, yeah, so one thing I'm gonna go through is kind of more or less testing out a atomic test, which is under T1086. This is the Bloodhound test. I'm gonna walk through different pieces of it with using Invoke-Atomic. And in this case, what I ended up doing, or I was kind of going through what we wanted to test with or mess with as far as for Atomic Friday. And I found the Bloodhound test and I felt like it was a little out of date. The original one looks like this. So if you've seen the YAML format, this is what it looks like. Give it the name, the description. And when I was looking at it, it just felt like it could use some love. There was very basic stuff in here. We do have a lot of new things that we can add to kind of bring it up to the newer standard for Atomic Red Team. And as far as like options that we could give this, and all we had in here was just this one test. And it was just invoke expression, run Bloodhound, and that was it. One thing I found when I was playing with it was it actually didn't even finish. It wasn't even completing. So I was like, well, it's basically a broken test. No one's really noticed, so we'll see what happens, right? So I went and modified it and worked with Carrie and Matt on this. And so we broke it up into 2 separate tests. And one of them will run a local version of Bloodhound. So it actually will go and, or Sharphound, it will actually go and download it to the disk, and then it will import it and then execute it. And so what we added here was different input arguments and dependency checks. What it looks for is, Sharphound PS1 needs to be on the disk. If it's not there, which is the test path here, if it's not there, go ahead and download that prerequisite. And the prerequisite is that Sharpound PS1. And so it'll go get the ingester and take care of that. And then once you get that prereq, it will, you actually execute it. So this will execute, it'll import the module, execute Bloodhound, and drop the zip file, which is your output result. So if you're running this against a domain controller, it'll output all that info to the zip file on local disk there. So let's just go ahead and dig in. A lot of talking and showing this. So showed the pieces that we changed. Let's go ahead and just do a little bit with Invoke-Atomic. Again, if you haven't played with it, it's really awesome. And PowerShell alone gives you that ability to do the tab complete. So in this case, I'm going to run show details brief. This is going to show me everything for T1086. And you can see here, we have 13 tests. You may notice number 10 is missing. These are based on whether you're running on Windows, Mac, or Linux. And that's the other powerful piece with Invoke-Atomic. It is cross-platform. So you can run this on Mac and Linux. Carrie, is that like, is there, I haven't personally played with it on Mac and Linux, but for like Linux, is there certain flavors of OSs that it's more supported with, or it's just anything you can install PowerShell on?
No, there's only 3 OS level settings, which is Mac OS, Linux, or Windows. And any finer granularity, you know, there are some tests that like are unique enough that that command only works on like CentOS or something, or even CentOS 7 or 8. And so the way we handle those finer grain details is with additional prerequisite checks, where you could say, check my prereqs, and I'll say, you're not on the right, you know, this has to be CentOS and you're not running it on there. And that's how you could find out that this test isn't for you. But the show details brief, it will hide, like we're running it on Windows, so it's hiding anything that doesn't apply to Windows. So that's why test 10 doesn't show up here.
Cool.
Yeah, Mike, as far as Invoke-Atomic Test is concerned though, yes, it will run just fine on macOS or Linux, so long as the open source version of PowerShell is present on there. So when I start running through my demo, I'll be doing it on macOS, and it works great.
Awesome. There you go. Matt's gonna do it extra live. Cool. So yeah, that's the show details brief. Now, if you wanted to see everything, you could kick off show details. And now this is going to expand all of that and show you more details of everything for each one of these tests. Yeah, so here's every piece of it. All of that's being pulled out from our YAML code within those atomics, specifically T1086. Something I saw and learned new yesterday was Carrie added this in here where it will highlight the, gosh, not the prereqs, it is the input arguments as red. So you're able to see real clear the input arguments for each test. And then also, if you're still running the test, if you're not executing with Invoke-Atomic, you still have the ability to copy and paste right out something like this. So it expands out the inputs, puts them right into a one-liner for you. So you're still able to go copy paste that and just execute, you know, a test at a time, which is really cool.
Wow. Yeah, I just learned about that input argument highlighting too. That's awesome, Carrie.
Yep.
Thanks for that.
So great. Yeah, so show details brief, show our details. Now I'm going to just dig into a specific test number, which is our local execution of Bloodhound Sharpound ingester. So again, I just want to see the details for this test in particular. So here's everything for running this from local disk. Again, we got all those highlighting in there. You'll notice the dependencies here at the bottom, checking for that prereq of PS1 on the disk already. And the cleanup commands are in there as well. So we're going to run through all of this here right now. Cool. Here we go. So that was show details. If you run brief on there, it's just going to tell you the name of the thing, the actual test again. So nothing exciting. I want to know now, I know obviously by looking at the screen that there are dependencies here or prereqs. So what I'm going to do is I'm going to hit check prereqs on this test. It's going to pull that up and say, yeah, you do not meet those prereqs for this test. What it's looking for is that PS1 file inside that source directory. And then it tells me run get prereqs. Okay, let's go do that. So I will hit get prereqs. It now kicks off, downloads PS1, and you can see it counting all the bytes moving on my networks. So, and on the right, I'm going to scroll down just so you get a quick idea of what we're going to hit here next. Here's the prereq command that we just ran. Okay, now that that's done, it is officially on dist, and you want to validate that, you could run your check prereq again, and it's much happier. It is met. Cool. So I want to run my test now. I have the PS1, prereqs are filled. I'm going to just tell it to execute T1086 test number 2. Hit enter. It now goes, executes, it imports that module, executes it, and then it's done. Now the way it works, again, is it will output that all the zip file. So this hit my domain controller, enumerated trust, all that stuff, users and things like that. So now you can take your reports and import that into Bloodhound itself. Yeah, pretty sweet, right? That's a pretty cool one. And then, yeah, if you wanted to just make sure that those are there, you can just ls your temp directory and you'll see the reports right here. So all alive and all well. Now that I'm done, because I just wanted to test this, I will most likely get some kind of alert somewhere, maybe my domain controller, maybe not an alert, but there will be trace events of this, you know, like on your domain controller, maybe some network IDS may have triggered on something, hitting your DC, things like that. So there will be some artifacts out there. But now I'm all done testing. I'm going to go ahead and run cleanup. And cleanup, which if you remember looking at our show details brief, or our show details in this test, it has 2 cleanup commands that it will execute for me here. The first one will delete that #pound PS1, and then the second one will go and delete the Bloodhound zip file. And that's as simple as running cleanup. That was all a little too smooth. And just make sure it actually worked. Cool. So yeah, so if you haven't seen Invoke, this is very, very powerful. As you can see, we just went through all that. We did our dependency checks and got the prereqs, and then we executed the test and got our report that we needed to import into Bloodhound. So I'm going to go ahead and stop sharing, and Matt, when you're set, I'll let you take it away, and I'll start watching all the chat windows and stuff and help out there if there's any questions.
Awesome. Okay. Can everyone see this okay? You able to read that text? All right. Cool.
Looks good.
Cool. I did want to briefly speak to some of the design concepts that Haig incorporated into his new test. So I'm going to just quickly run through like some of the updates that he incorporated into the Bloodhound test. The first being dependencies. So the idea behind an atomic test is that when you write one of these, it should be self-contained, ideally. So if there are any dependencies that need to be pulled in outside of that otherwise self-contained test, this is exactly what dependencies are for, right? So the prereq command is going to validate whether or not that dependency has been met. And if the dependency has not been met, then there's separate code that you can implement to go satisfy that dependency. And so from a design perspective, I really like having that abstraction and separation should something outside of the otherwise self-contained atomic test need to pull something in. Because we want to really eliminate as many assumptions about dependencies as possible. And we really should just be as explicit as we possibly can. Even if it's something as simple as pulling in the contents of a file that you know to reside in the same directory as where the atomic YAML is. Like, we still want to consider that to be an assumption, because that's not always going to be the case with everyone's atomics folder. Everyone may have their own unique atomics folder. We don't want to assume that you're just pulling from the Red Canary repo atomics folder. And then what Hank just showed off, the cleanup commands, I really like this as well. We definitely want to try to be as relentless as we can to clean up any relevant artifacts that, that the test will generate. Cool. So I'm showing you some YAML here, and you know, like as a human, it's certainly easy enough for me to read through this and make sense of what all is going on. And Haig also demonstrated like how you can kind of parse through this and get some context by showing the details in Invoke-Atomic Test. So that's fine and all, but what happens when you want to write this stuff? I don't know about you, but I personally just do not like writing YAML. Well, I not only don't like it, but I don't trust myself that I'm going to screw something up. Like, it's just raw text. The syntax is intuitive enough that it will usually like throw an error if I have some kind of syntax error, which like happens all the time with me. And me being like a huge PowerShell fanboy, one day I asked myself, like, can't there just be code to write all this stuff for you? Because I already have like my established PowerShell workflow, which I'm comfortable in. Now, not everyone may have that same established PowerShell workflow that I do, and obviously that's okay. But also, what if there were situations where we wanted to have the ability to build automation to automate the creation of atomic tests? If you're just hand jamming YAML into what is effectively a text file, well, then that's not possible, right? So again, I wanted to support my PowerShell workflow, and two, I wanted to support having code that could generate tests for me if that was a use case that I wanted to be able to exercise. And so with that, allow me to show you some of the new functionality that was incorporated into Invoke-Atomic Red Team. All right. Whenever I'm working with a PowerShell module that I'm not keenly familiar with, one of the first things I'll do is I'll import it, and then I want to know what functionality is publicly exposed via that module. So what I usually do is git command -module. And so what is new in Invoke-Atomic Red Team are all of the new dash functions. So this is the code, the PowerShell code that allows you to automate building atomic tests and atomic techniques. So I'm gonna get into those here in a little bit, but another thing that I recently breathed some new life into was the existing getAtomicTechnique function. So previously what this would do is it would read in the raw YAML and rely upon a third-party PowerShell YAML module to parse that raw YAML and convert it into a hash table. Hash tables are easy enough to work with, like in any language that you may be familiar with, certainly like Python. But this being PowerShell, I personally prefer that I have like a proper PowerShell object to work with. Not only that, previously Get-Atomic technique would just parse the YAML, and that's it. It didn't actually validate that the YAML from an atomic test or an atomic technique validated against the expected schema for an atomic test or technique. Get-Atomic technique does that now, okay? So let's take the YAML that Haig was working with for the test that he just highlighted. And so I just pulled in the raw YAML, so nothing fancy at this point. So I could eyeball that and see if that looks fine, but again, I don't trust myself to validate YAML as a human, so I'd rather have code to do that. And so I just ran Get-Atomic technique, specifying the path to the YAML, and by the nature of it not returning any warnings or errors, I can be confident that it was properly parsed. And because it was properly parsed, it output a proper PowerShell object for me. So let me save this to a variable. Actually, this is a technique. And then we'll just quickly poke around this object that's returned. Oops. So we have the attack technique, display name, and all of the corresponding atomic tests. Okay, so proper PowerShell object, but the way the objects were designed was to output them in a fashion that looks almost identical to what you would see just reading through the YAML. But having it in a proper object also allows me to write code. Let's say like if I want to run metrics on an entire atomics directory. For example, I was asked recently, like, what is the percentage of Mac OS versus Linux versus Windows tests that we have? I now have automation that can easily supply that answer. Another cool thing is that it now supports pipelinable input. So I could just do an ls on the entire atomics directory. And as like a quick sanity check to validate every single atomic technique within the atomics directory, if I don't get any warnings or errors, then I'm probably good to go. I did see one warning happen to scroll by, so that might be something that I would want to triage at some point and maybe do a PR to fix this. Anything that is presented at the warning level is just indicating like, hey, it would be nice to have this fix in your atomic technique. It's not mandatory though. So in this case, it says the following import argument is defined, but it's not actually used, temp folder. So I might go back to T1055 YAML and investigate why the actual test doesn't employ temp folder. 9 times out of 10 from my experience, it's just a copy and paste fail from another test that happened to use that input argument that is no longer relevant to the new test that was written. All right, cool. So that in a nutshell is how I now go about discovering atomic techniques within an atomics directory, and also starting to be able to like run statistics through code on whatever atomic folder I happen to be working in, whether it's the public one or an internal one that I might be working with. Now, going back to the updated Bloodhound test that that Haig wrote here recently, this one here. I just wanted to show you like the one-for-one copy of how I would translate this over to PowerShell code. So it might help for me to start down below here. And by the way, after this webcast, I'm going to pass all this over to Haig to incorporate into his notes so that we can make this public for everyone. So I'm going to start with the new atomic test function. And I've specified all my arguments here. And by the way, there's very detailed help for all this. So you just do help, new atomic test. All right. So you've got descriptions for all the parameters, fairly detailed description of the output, and example usage. All right. So what we have here, the name of the atomic, the atomic test, supported platform, and some of these actually supports tab completion. So like supported platforms. So I'm going to hit tab. I can just tab right through those, which is kind of cool. Other ones that support tab completion would be like executor type. So we got bash, command prompt, PowerShell, shell. Cool. And then here's the contents.
Is it just me, or I wasn't seeing what you were typing in your examples there?
Oh, you weren't seeing that at the bottom?
Maybe.
Are you able to see me scroll?
We got some comments on the chat. Yeah, I think it's just the Zoom window has a little border at the bottom, so we can't see the very bottom.
Oh, okay. I'm sorry. Right here. So what I was doing here was just you type in, like in this case, executor type, and then space, and then you could just tab complete through the supported options. So that I'm not good at memorizing these things. So when tab completion makes sense, when you only support like a finite set of options, PowerShell is great at allowing you to do that. All right, so back up in my top window here. So here's like the main contents of the test and the description and the executor. And the way I just designed this was that because you can supply more than one input argument and dependency, I created dedicated functions to create those, right? So Haig's test here has 3 input arguments. And so here I have 3 calls to new dash atomic test input argument. Now that's a little verbose for me to say, it's a little verbose to type, but it being PowerShell, you get tab completion for free. So new dash atomic, and then just start hitting tab, and you don't have to type all that out every time. And then finally, Haig had 1 dependency defined. And so I've defined that here using new atomic test dependency. Okay. So if all works out as planned, I'm just gonna execute all this here. Clear my screen a little bit. And we should have as a result is a properly formatted PowerShell object consisting of the atomic test. Now, this being a proper PowerShell object, and with how the PowerShell YAML module was designed to work, what's kind of cool about this is that I could just take this raw PowerShell object, which represents an atomic test, and pipe it to convert YAML. And so I could just add this directly to an existing atomic technique. Okay. So that's all I got. So sort of to summarize all of this, while to the untrained eye, this may look like perhaps more characters that were required than the raw YAML test that Haig wrote here. I accept that, that potential criticism. But this being PowerShell code really allows me to have a process to automate the creation of tests if I wanted to do that. And it gives me an additional sanity check. So when I call new atomic test, it will output a warning or an error if I screwed up with something. For example, if I happen to forget internal domain, as an import argument, let me just re-execute this. I get a warning saying the following input argument is defined but not utilized, internal domain. Or what if I forgot to define output path, but in my test, I actually use it. So that was input argument 3. Let me remove that from here. Oops. Wrong button. Okay. So the following input argument was specified somewhere in the atomic test, but it's not actually defined anywhere. So that to me should be like a breaking error. Like this is not a trustworthy test at this point because something is attempting to be used that's not actually defined. And so you get that the error level warning versus the warning level accordingly. Okay. Cool. So I'm going to pass things back to Haig.
Sweet.
Yeah, Damon over in the chat says this is great. I agree. When Matt first did this, he got a lot of errors from stuff that was already in the repo that he got to clean a lot of stuff up, and that was very handy.
Awesome.
Yeah, there's certainly a lot of power with the new atomics. I also wanted to share here, these are also located under the wiki under helper functions. And so Matt created a nice page. You can click on new atomic and then you will see all of the new items here. And all the codes obviously within the same repo. You can find it just under the main drop here, main page of the Invoke. And that is all available there. So yeah, those are great. So we have a little bit of time, which is awesome. We wanted to show live executing tests remotely with Invoke-Atomic here as well. And so again, I'm using Detection Lab. So I have multiple Windows machines and a domain controller. And what I'm going to do here is show from my Windows 10 machine, I'm going to set it up to kick off 2 different atomic tests on the remote Windows Server 2016 box called WEF, Windows Web Forwarder. And so on that box, all I would ever have to do is, every environment will be different, but in my environment, what I did is I just put into PowerShell, the terminal, enable PS remoting, and that was it. It's kind of sounds a little too easy, but that was really it for me at least. That is here in the wiki as well. And then Carrie and team had also put in the how to do it from Windows to Linux, Linux to Windows. So you have all these options in here. Every environment will be different. I found that when I was working on this initially, I was running into all kinds of errors And so in my notes at the bottom here, I dropped in a couple of things like you may find a place where you have to put your user account inside the remote management users group, even after enabling PS remoting. So it's kind of a random thing. And Carrie also made mention here on the wiki, you may have to run skip network profile check if your client is using public network profile, so kind of like a firewalling thing. So it's kind of random. Oh, and then I found when I enabled PS remoting on my server, the WEF server, I had to do it as the administrator account, not the domain account of Vagrant. So if you know Detection Lab, you're generally logged in as that user Vagrant. So that was kind of a weird thing, but I don't know. Every environment's gonna be a little bit different. That's just kind of what I ran into. First time I tried this, like a while back, I ran into, I was having these errors and I was disabling firewalls and enabling all kinds of random stuff, just going after every piece. So yeah, so it could be a little bit different, but generically, if you're using Detection Lab, you enable PS remoting as the administrator account. And then now where we're going to begin is just on our Windows 10 machine. And again, all these notes are on the wiki, and then I'll also share my notes when we're finished. So I'm going to first create a quick variable called session or ses, and all we have to do is put in that computer name and the credentials we're going to use, or at least the username here, and it's going to prompt us. We just paste this in, hit enter, there's my prompt. You notice I'm using that administrator account for Detection Lab. Just type in that password, and then that is it. So we have a new PS session ready to go against the Windows Event Forwarder machine. And so now let's get remote. So first thing I'm going to run is we already played with Invoke-Atomic a bit ago. Let's check out these other tests that I'm going to run. So I've already got this kind of queued up. So I'm just gonna show us the details of T1117. If you haven't seen T1117 before, it is the good old squibbly-do execution using regsurf32 and all the awesome. I just love seeing this in red. It's so cool. But that's the details for our test. Now let's go ahead and just push this to our remote server and execute it. And it's as simple as just saying, you probably already see it on the screen. You just type session, drop in that session we had already set up, and we're good to go. And it goes off, does its little trick, and that's it. You're like, wow, Mike, there's no, like, you like expect something, like in a little firework explosion or something, right? Anyway, I'll show you the results in a second, but I'm gonna go ahead and kick off the second test that I have in here, which is T1003. So I'm just gonna go up here. Let's look at the details of T1003 before we execute it. Like, what is this one going to do? Here's our details. So this one's going to be a credential dumping test. This will dump registry dump of SAM, creds, and secrets. So this one's going to be executing reg on that remote machine. And then you can always run like a cleanup command. And so I guess that's a really good thing to bring up, Carrie, is you have the ability to do remote prereq check and get prereqs. Is that correct?
Yep. If you give it a session, it'll do the prereq check against that remote system, and it'll also do the cleanup against the remote.
Nice. That's exciting. So yeah, maybe we'll run this one.
We might mention a little bit why we might want to do something like this, execute against the remote. And so an example is maybe on this remote machine, we don't want to install Atomic Red Team because that involves installing a PowerShell module. That involves a download of a big Atomics folder full of a lot of things that might execute alerts, even for tests that we might not even be planning to run. Maybe we just want to run this one test in a certain environment, and we don't want to do all the install of all this stuff. We just want to basically execute, in this case, those 3 reg commands. that you're showing there. And so this would allow us to do that. All we have to be able to do is establish that PowerShell session. We don't have to install any Atomic Red Team, anything, and it'll execute those commands.
Yeah, that's awesome. Yeah, so here is that test against that remote box as well. And it will finish here in a second. While that's queuing, I want to then start digging further and just make sure these things had actually executed. That one's taking longer than usual. So I'm gonna flip over to Splunk real quick. So Detection Lab does come with Splunk installed. I just created a quick query just to show me in the last 30 minutes, the last RedSurf 32 execution on that Windows Event Forwarder machine. So I'm not creating tables or anything pretty, but if you've never played with Splunk, obviously there's a lot of power here, and just kind of shows me generically that this is here, process had executed, and you'll get your different sources. So sysmon, PowerShell transcript, 4688 events, things like that will be there. And this guy's taking a while. Otherwise, once that one completes, we can look at that in Splunk too. But yeah, that is all I got. Probably mad I've done this 12 times or something.
Yeah, I mean, I'm still constantly impressed by how seamless the remote invocation can be. That's testament both to Carrie's design of it and testament to how seamless everything can be once you have an established PowerShell remoting session. Well, one or more PowerShell remoting sessions. So it's really cool stuff.
There you go. Cleaned it up. Run it again, see what happens. There we go. Now we got all three, and we saw that one of them had ran in Splunk. So let's see if the other ones will show up now. There we go. So there's all three. Cool. Just enough time for questions. Let me re-share my awesome slide deck that we got some excellent feedback from on Donahue on. Yeah, if you have any questions or anything like that, drop them in Slack or in the channel here. We do have, if you haven't signed up for Slack, it is on the atomicredteam.io page. The link is on there. If you have any questions, or if you're working on things in a week or so, you can always email us at research@redcanary.com. And previous Atomic Fridays, just Atomic blogs, things like that are all on the redcanary.com/Atomic Red Team page. You can again also hit these on atomicredteam.io. But let me kick up the chats here.
Yeah, so we did have a good question from Jack on chat that says, so if we don't have detections for a given test, are there references to tools or things that may alert on them?
Don't think we have any reference to different tools. Generically, we always run, most of us, I guess, well, we always run sysmon to just more or less see if execution had occurred. But obviously, like in your own corporate environment, if you want to test your products or just validate those things, you'll have those tools installed so you can see from there.
Yeah, I mean, the way that I tend to frame atomic techniques and atomic tests is that of it's a framework to specify what you would determine to be like a true positive test case representative of a technique. No more, no less. So how you choose to interpret the relevant telemetry or detection artifacts, we intentionally leave up to you. So, yeah.
Okay, so another question. Someone says they joined late, but they wanted to talk a little bit about the difference that this PowerShell execution framework has from the other Ruby and Python execution frameworks. So I can speak a little to that. So at a basic level, Atomic Red Team is really that atomics folder full of technique number folders. Inside each technique is a YAML file describing the test. You know, here's how you run Bloodhound. You type in this command and it runs it. You can just copy that command, paste it in the command prompt, and it runs the attack technique or that atomic. But doing that gets a little hard to do manually because, especially with input args, you're replacing those input args and doing those prerequisites manually. So that's where the execution frameworks come in. They read those atomic test definitions and they just follow the directions. They execute the commands it says with the input args it says in the proper execution environment, like maybe it's supposed to run in PowerShell or from the command prompt or SH or bash. And so it just does that for you. You just say run this one. So it's kind of a menu and where you can just run things. So there's 3 different execution frameworks that are available now to do that for you, the Ruby, the Python, and the PowerShell. So some of the differences I can talk about. They all have the same basic idea. They're making it easy for you to run an atomic test. The Python has an advantage in that Python is installed and available already by default on Linux and Mac OS, where to use the PowerShell one, you would have to install PowerShell Core on those OSs, and that might not be a viable option for you. Some other differences, the Ruby runner hasn't been updated much over the last year. So I'm not sure how up to date it is, but it definitely doesn't support a lot of these newer features with prerequisites and dependencies and cleanup commands. In fact, I think the PowerShell invocation framework is the only one that pays attention to dependencies and prereqs at this time and cleanup commands. I've heard some community members talking about updating the Python runner to support that, and the Python runner has been updated recently, but it is missing some of those core features. It doesn't have the cross-platform, you know, Invoke-Atomic on a remote machine feature added to it yet. So in terms of like the most amount of features, that's the PowerShell execution framework at this time. But of course, any of you could get in there and contribute and bring those other execution frameworks up to speed to support some of these newer features that have become available in the last 6 months. Let's see, you guys see any more questions in there? Just trying to read and talk at the same time.
We did get one in the Atomic Slack about when will we update and change atomics for the new MITRE subtechniques.
Matt, you want to speak to that?
Sure. I was waiting for.
I'll take a stab at that. So, hey, Carrie, myself, Keith, and several others, we meet every other week just to chat, like, you know, what is the status of like general maintenance of the Atomic Red Team repo and the Invoke side of the house as well. And so this certainly came up recently as a point of discussion, and we haven't settled on anything yet. But I did briefly investigate like the ease with which or difficulty in which doing that transition could happen. And from like a technical code perspective, like it's pretty easy to do, like, because MITRE was great in what they supplied in the form of like a one-to-one mapping of like, hey, here's the old technique and here's either the new parent technique or the new sub-technique that it maps to. It's just a one-to-one correspondence. And I believe like something in the like the 90% range of the existing tests that we have correspond to that one-to-one mapping. There are some design decisions that could be considered. For example, like currently in the atomics directory, we have everything broken down by folder of MITRE technique. So really it's just a design discussion of like, do we want to have subfolders for techniques versus just having a root folder for all parent and sub techniques. More on that to come. We honestly just got to put our heads together a little bit more, come to a consensus, and then make a decision on something. But again, from a technical perspective, like cutting over to the new sub techniques is going to be easy. We just have to be consistent about that transition. So we'll obviously stay tuned in the Slack channel, and we'll certainly keep everyone apprised of what our plans are.
Awesome. Well, I think we kind of hit it here, but yeah, any other questions and whatnot, we'll follow up in the Slack, or if you have any other questions, drop them in Slack, and we'll see you then. But thank you everybody for joining. Thank you, Matt. Thank you, Carrie. Appreciate everything. And yeah, thanks everybody. Thank you for being here today.
Yeah, thanks everyone for your time. Really appreciate it. Take care.
Yep, bye-bye. Thank you.